on just natural log. So actually I'll just put that derivatives of natural log of u. Okay, and I'm putting natural log of u because that u, kind of like it does with u substitution, just can represent anything. It could just be x, it could be x squared plus 1, it could be, any number of things. But the point is there's something in there that doesn't just have to be x. So the rule for taking the derivative of a natural log is simply this. You take the derivative of that inside part and you divide by that inside part. So you can call it du over u, or another way to say it is it's the derivative of the inside over the inside. Derivative of the inside over the inside. So if you notice, the natural log disappears completely. Now it may stick around if you're having to use the product rule or the quotient rule or the chain rule, just because of the way those rules work. But for just a basic derivative of natural log, the natural log part is going to disappear. So let's do some examples with that. Let's say we do the derivative of the natural log of x. We'll just do the basic one. Well, my inside is x, the derivative of that is 1, and I divide by x, because that's the inside. So it's the derivative of the inside over the inside. Okay, let's try another one. Let's try the natural log of 2x. The derivative of the natural log of 2x. Okay, the derivative of 2x is 2, and you divide by the 2x. If you notice, the 2's cancel out, and it just leaves you with 1 over x. Now, it's not going to cancel out to 1 over x every time. But if you're curious why it does work out that way, you need to consider the properties. So think about this right here and what you could do with the properties. We're multiplying 2 times x, so I could write this as natural log of 2 plus the natural log of x. Just so you know, you don't have to know what I'm about to say, but I just wanted to show you why the natural log of x and 2x is the same. Okay, the natural log of 2 is a number, so when you take the derivative of it, it's just 0. And then the derivative of natural log of x is 1 over x. So that's why those turn out to have the same derivative. Okay, next let's look at the derivative of the natural log of x squared plus 1. You do the derivative of the inside over the inside. So hopefully you can see the rule's not all that complicated. You just do du over u, derivative of the inside over the inside. Now, like I said, you may sometimes have to do some of the rules we've learned before, product, quotient, and chain. So look there for a second and see if you can figure out what rule we need. We would need the product rule, because it's x times the natural log of x. So f will be x, and g will be the natural log of x. F prime is 1. G prime would be 1 over x, derivative of the inside over the inside. So we get f prime times g, that's 1 times the natural log of x, plus f times g prime. Well, x times 1 over x is just 1. Alright, now let's look at one more. Well, we'll look at several more. Let's say that our original function is the natural log of x all cubed, and they ask us to find f prime. So they ask us to take the derivative. Okay, I picked this example on purpose. Some people are tempted right now to say, oh, the properties of logs, let me move that down and say that this is equal to 3 natural log of x. That's not true, though. If you look back at the property, let me see if I can get back to it. Here we go. The exponent here is not applying to the entire log. It's only applying to what's on the inside. So since this cubed on our example here is applying to the entire logarithm, we cannot apply the properties of logs. So instead we have to use the chain rule. We've got an outside function, the cubed, and an inside function, the natural log. So we do the chain rule, derivative of the outside gives you that, times the derivative of the inside. You're welcome to leave the problem just like that. You could also simplify a little bit and write something like this, or even something like this. It's really up to you. I'm not picky either way. All those are valid as far as I'm concerned. Now I want to show you two examples that will hopefully show you why I bothered reviewing those properties of logarithms with you. So first of all, let's look at the natural log of the square root of x plus 1. As that's written right now, to do the derivative of the inside over the inside, let me label this as f of x, it would require the chain rule. You'd have to do the derivative of the square root of x plus 1, which require the chain rule. And it'd be nice if we could avoid that. So here's what's going to happen. Now I'm not taking the derivative, I'm just rewriting the original function. I know that a square root is the same as having a power of 1/2. And that 1/2 can be moved out front as a coefficient. And now all I have is a coefficient, and x plus 1, which doesn't require the chain rule. So I've simplified it a lot. So now if I take the derivative, I get 1/2 times the derivative of the inside over the inside. You can leave your answer just like that, or if you want, go ahead and distribute the 2 through the bottom, and you get that. So hopefully that kind of gives you an idea of why the properties are helpful when we take the derivative. So let's look at another one where I think it'll become even more apparent how helpful it is. Let's say we have the natural log of x times x squared plus 1 squared all over the square root of 2x cubed minus 1. If you don't use the properties of logs here, you have to do the product, quotient, and chain rule all combined. But through the magic of the log properties, we know we can split this up and call it the natural log of x plus the natural log of x squared plus 1 squared minus the natural log of 2x cubed minus 1 to the 1/2. And I'm going to take that one step farther, move the exponents down as coefficients. So please notice I have not taken a derivative yet. This is still my original function. I'm just rewriting using the properties of logarithms. And now, because I've rewritten it with the properties, I don't have to do any product, quotient, or chain rule at all. So now I can take the derivative, and I do the derivative of the inside over the inside, plus 2 times the derivative of the inside over the inside, minus 1/2 times the derivative of the inside over the inside. And I would go ahead and simplify this one. I would go ahead and put those coefficients in. So 2 times 2x is 4x, and 1/2 times 6x squared is 3x squared. So basically I'm just canceling out the 2 and the 6 there. And that would be my final answer. And that is a whole lot simpler than trying to do the product, quotient, and chain rule all combined. Okay, so now hopefully you feel ready. The homework for this section is page 322. And I want you to do number 45 through 59, and also number 71 part A and number 72 part A.